Hello, my name is Janakiraman, and today I'll be presenting my final year project on the topic the discovery of novel biomarkers using multivariate modeling in major depressive disorder. The flow of today's presentation will be me introducing the topic in the project, followed by a comparative analysis of the different pipelines that have been used, then a gene set enrichment analysis, and finally a discussion on the conclusions and future work. To begin with, let me introduce the topic. Major depressive disorder is a psychiatric condition that can affect a person's mood, sleep, focus, and cause feelings of guilt and worthlessness. It is often confused with bipolar disorder or schizophrenia because of the way it presents itself in people. The problem statement in this project is that the data that is associated with such disorders are high-dimensional transcriptomic data with small cohorts but a large number of predictor variables. This makes it difficult to effectively classify the blood biomarker data in order to make an accurate prediction. The data that has been used in this project has been taken from the gene expression omnibus. It has information corresponding to 203 patients, out of which some of them were on placebo, while the others were given the treatment drug called duloxetine. At week 0 and week 8 of the treatment, values corresponding to several gene probes were recorded along with their age, gender, and treatment type. The objectives of this project are twofold. A. We try to predict the response to the treatment. B. We try to classify if the patient were on placebo or duloxetine. The experiments overview that's been employed in this project can be summarized in this flowchart. We can see that across the 4 pipelines, we have used a filtration technique followed by a classification technique with RFE. Pipeline 4 is targeted at solving objective A using clustering with topological analysis. All 4 pipelines end with a gene set enrichment analysis. Next, for the comparative analysis, Pipeline 1 uses selection by false positive rate as its univariate testing method. For objective A and B, the following alpha values were tried, and the number of features extracted at each stage can be summarized in the slide as shown. For Pipeline 2, a Lima model-based filtering had been used, which extracts 10 differentially expressed genes, which is much lower than the number of genes which were extracted from Pipeline 1. Pipeline 3 uses a method called selecting by k-best features as its filtration technique. This technique can be tailor-made to each of the classification techniques used in the next step. Then an intersection of genes has been taken. This technique is effective because it allows a relevant ranking of the features with the classification technique. Pipeline 1 produces the best results, and it can be summarized as shown in this slide. We can see that for both objective A and B, across the different alpha values, the performance of penalized logistic regression and SPM is much better than that of decision tree and random forest. Based on this, the following points can be made to summarize the model performances. Pipeline 1 uses univariate filtering with RFE that performs the best. Across all the pipelines, logistic regression and SPM perform better because they are better at handling high dimension data and overfitting issues, and these pipelines are better at predicting the response type over the treatment type. Pipeline 4 provides a unique approach to solving this issue, which uses clustering techniques on topological networks. After doing a PCA on the data, an HDB scan clustering algorithm is used to create pure clusters. Pure clusters are the ones that have data points belonging to a particular category of response. It was observed that data points within each of these clusters had the same gender, treatment type, and similar ranges in age and gene expression data. Then a gene set enrichment analysis was performed, and comparing with past studies, 4 genes have been highlighted in this project. 1. SGLT2, which is associated with an improved glucose profile in depression symptoms. DIO1, which is related to producing thyroid hormones. Or OR2A14, which is responsible for transmitting signals between the olfactory organs and the central nervous system. And finally, REM1, which is associated with calcium signaling and angiogenesis. With this, we can move on to the discussion on this project. To conclude, variances across the cohorts seems to be better at reducing the number of features. Logistic regression and SVM outperform random forest and decision tree classifiers. And finally, the clustering with topological analysis provides certain unique observations that can be drawn from this data. This paves the way for future work that can be done on this topic. The first is to apply these pipelines on wider transcriptomic data that use a larger population, which will help us validate the observations made in this project. We can also do a comparative analysis across different stages of the treatment. It would also be interesting to combine studies done on this topic along with studies done on bipolar disorder or schizophrenia, which will help us understand mental disorders a bit better. With this, I would like to end my presentation for today. Thank you so much for your time, and I hope you enjoyed the presentation.